So my wife Emma and I bought a house. We got the keys in about February 2020, and we really wanted to. The house is in massive need of renovation. So we wanted to really do right by the house, by the future occupants. So we wanted to insulate it as best we could. So what I'll do is just go through what we did, talk about some of the things, the considerations that we made, and I'll caveat it by saying this isn't a specification or a how-to. It's just a sort of what we've done. So this was the house. It was quite dated, lots of rotting carpets and vinyl. A lot of the plaster work on the walls was falling off or coming away. And a lot of rotting and not very usable rooms. The bathroom, and upstairs. So I think one of the things that was really on my mind when we were starting this project was, we really want to insulate this so we can obviously reduce our energy consumption, personally, our costs, but then also thinking about the broader climate crisis. Carbon emissions are a big deal, as we all know, but we also need to manage our finances. And the statistic that stood out for me was that 80% of the homes that exist, 80% of the buildings that will exist in 2050, which is what we're aiming for net zero, already exist. So renovating houses and insulating them very well is really, really important for us to achieve net zero. So that was a really big consideration for us. What I got really excited about was potentially doing this to a Passivhouse renovation level, which is called Retrofit. It's a very high level, it's very difficult, but I saw that other people had done that, so I'd done quite a bit of research on that. As I go through, you'll see that didn't quite get anywhere near that. It's very difficult. We had a lot of will to do the best that we could with this in terms of insulation levels, but we had to call our sort of level in terms of cost that we were able to achieve. So this is just, we basically had to strip everything out because it was either rotting or outdated or broken. So I'll start with the floor. The original house had a suspended timber floor. Now, in order to insulate that, to improve the efficiency of that floor, we would have had to do a lot of quite tricky work around walls, some stairs. There's another picture coming on the stair. The cost and complication of that was a little bit difficult. What we did decide to do, obviously, with a lot of this work was to do it ourselves, because then we could then save a bit of money in terms of labor costs. It would mean we could then spend a bit more on some of the materials and finishes. So what we ended up deciding to do was take up the floor, because these suspended timber floors in these older Victorian houses rely on ventilation underneath to remove all the moisture that sort of comes out from the heated space. What ended up happening was maybe 30 or 40 years ago, there was a small extension out the side here, and they put a concrete floor in, which then blocked up some of those vents, which meant that there wasn't proper ventilation under there anyway. So in order to make that work well, ventilate that well, it would have been very difficult and a lot more time consuming. So we decided to go and explore some sort of more appropriate solid floor options for a masonry building, which meant taking it all out. We've kept all of the wood and all of the stone. So this is Charlie over there helping us, and Eva helped us as well, taking down some of these walls. Insulating this well. The key thing with insulation is consistency. So having a consistent sort of wrap, if you think about putting an insulation jacket or something on, having that all zipped up really makes a difference. So connecting the insulation on the wall and the floors and the roof really makes a difference. So when you have junctions around stairs and things like this, it gets very difficult to do that in a consistent way without losing too much heat. So we took all that out. So you can see the stairs suspended here. So what we opted to go for was this try and maintain, because it's a solid masonry building, we wanted to maintain the breathability. With these buildings, they're sort of designed to regulate the moisture that's within them. So if there's moisture buoyed up inside the house, it's absorbed into the walls and the floors, and then when it gets a threshold, it sort of equalizes back into the room. A lot of new builds now are designed to be sealed and airtight, so there isn't that moisture kind of movement as such. So using modern materials in the floor would have sort of hindered that moisture movement. And often with these older buildings, there's a lot of quite poor advice in terms of addressing damp issues. There's a lot of talk about rising damp and some of the, thanks, Nance, mold issues around that. The exact cause of that is often because those ventilated floors are not properly ventilated. But the trouble is, what then ends up happening is people put in inappropriate measures to address that, and it doesn't get dealt with properly. So this is a floor insulation, which I've got some you can see a bit later. Maybe you can pass it around. It's a recycled glass. It's quite light. It's got, part of the reason we chose it was because it allows that breathability of moisture, and it's also a much lower carbon, embodied carbon to actually manufacture it and move it around, compared to something like a plastic kind of modern insulation. So you just lay it down on this geotextile, and then it gets compacted into a level surface. So that's Emma, my wife, raking to get a level surface, and then we use the whacker to get it compressed. Another layer of geotextile. And then, because many of you may know, we're in a radon area, building control recommended that we put down a radon barrier, which does then start to impact on that permeability of the moisture. But what it meant was that if there's any moisture, if it's very wet, for example, raining and stuff, there's a lot of moisture in the ground. That can be called moisture pressure that can come up into your floor. So having this allows the moisture to come up into that zone a little and then subside and not get pushed into the walls. So then we put this barrier down to stop any radon, which kind of takes me on to the next thing about insulation. So with insulation, you want consistency, and then you want to make sure that you're kind of sealing up the gaps. And there's some good draft excluders there. That's a different initiative, but do have a look at that. Sealing up gaps makes a big difference to your energy efficiency and drafts. So what we did with this was make sure we taped our membrane down to the walls. It's quite difficult taping to old bricks, but we got there in the end. We then laid all of the underfloor heating pipes ourselves. And the reason we went for underfloor heating pipes is because from a heating point of view, particularly because we got effectively 3 floors, including the loft that we're kind of renovating, having that really consistent temperature at the lowest point of the house gives it a very good gradient all the way up. It also means that the boiler is running at a lower temperature in terms of heating up the coils, compared to bigger radiators, for example. And it's a much more comfortable temperature. So that was a big consideration for us in terms of what energy source are we going for. Did a lot of research into air source heat pumps. We looked at hydrogen fuel cells. We looked at solar panels, and there's a very interesting solar panels with heat pump technology linked in. I won't go into details there. We would have liked to have gone down the air source heat pump route, but a key thing to know with that is that in order for it to run efficiently, you need to have good levels of insulation, and your radiators need to be sized to run on a lower temperature so that your air source heat pump's running as efficiently as possible. Unfortunately, we were quoted something like £14,000 to get it installed, which is just a no-go for us. So the next best thing for us was getting the most efficient boiler we could get, and then making sure that the radiators that we put in upstairs were sized to run at a lower temperature, so our boiler's not working as hard and we're getting that efficiency and saving. What was the other thing? And then just a side note, for our hot water, we decided to use a smart cylinder. that also connects to solar panels. We don't have the solar panels yet, but we can do that later. But the hot water cylinder is a smart cylinder, so it learns when we need the heat, and then only heats up as much as it thinks we need, rather than heating the entire cylinder all the time. So there's some savings there. So I think what we've tried to do is just do all these lots of little marginal gains as far as possible to make it as energy efficient as possible for us. And then on top of the insulation, we got someone in to do a limecrete slab. Again, that limecrete is, it's got a much lower carbon, embodied carbon sort of amount compared to a concrete slab, but it also allows the breathability. So it allows the moisture in the room to be regulated. It sort of absorbs the moisture when there's overload and then releases it when there's a deficit. It's a great product, and I bought these through a company in Wales. There's a couple of good distributors that do some good natural building materials. So I'll go into walls now. Just check I haven't missed anything. So, wall insulation. We wanted to insulate our walls. The construction of the majority of the house is basically solid brick. There's no cavity, not super insulating. So we needed to be quite careful about how we maintain that moisture, or sort of regulate the moisture in that, because a lot of modern products are cement-based for renders and plasters and things. They can end up creating issues in your wall. If you get moisture trapped in the wall, it can then freeze and thaw and sort of break the structural capacity of the walls. There can be mold, there can be all sorts of issues. So what we wanted to try and do is maintain the breathability of those walls so it could regulate the moisture. The reason we went with internal insulation on the majority of the external walls is because on the outside, particularly on the front, there's these lovely stone surrounds on our windows, so we want to maintain that. The sort of historic features were a consideration in our choice of material or insulation, and I'll come on to that a bit later. But so we went for this wood fiber product. Again, it's a natural product. It's very low carbon in terms of its manufacture and use, and it can be recycled after its use. And here are some examples which you can have a look at afterwards maybe. It comes in various different formats, and we used a board. We spoke to the suppliers quite at length about the exact specification and things, and they're very helpful. They have particular systems that they use for the whole thing. And in terms of the thickness, we actually went for about that much, which is about 40 millimeters, which kind of just takes the edge off it a little bit. If that was 40 millimeters of a sort of PIR plastic insulation, you would get a much higher insulating level, but then there's a much higher risk of getting condensation and issues with moisture in the walls. So we stuck with this product, and it was very easy to use and work on site. You apply an adhesive on the back, stick it to the wall, and then you mechanically fix it by drilling into the wall and then fixing these plugs. And then there's a pin that fixes into that. It's all very straightforward, all very doable. So this was our living room, just making sure our cabling is correctly done. And you can see all the plugs kind of fixing into the walls. Occasionally we'll fix into a mortar joint, which is all lime mortar, so it's quite loose, so we'd have to rearrange and do some elsewhere. And then this is upstairs. So we've only insulated those external walls. The party wall we didn't insulate because you don't have, I mean, you're expecting the neighbors to have the heating on, so there's not as much heat loss. And then what we made sure was that all of our new floors and walls were insulated as well. That just keeps it much cozier. It really helps with the acoustics between rooms. And for that, we just went with I think it was a glass fiber insulation from B&Q. But you can get a wood fiber version, which is a sort of flexi stuff. You just stick it in. And then this is the living room after we had finished with the insulation. In order to maintain that breathability, then you need to use a breathable plaster. So we looked into various different options for this, particularly looking for natural-based and low-carbon options. And lime plaster is obviously very traditional around here, and had been used in older buildings. We looked at clay plasters. Clay plasters are really great because they can also help with regulating that moisture. You can put pigments in them, and they look fantastic. Unfortunately, they're incredibly expensive, which we found with a lot of the natural building products, which is a shame because, when it's so much cheaper to do it with a sort of manufactured product that's sort of much more carbon intensive or not as great for the environment, it's really hard to make that call on going for something natural. So you got to find the right level for you. And then, so we went with this plaster in here, which gave a really nice smooth finish, really nice texture and color, and we've actually left it raw. We did go with a gypsum-based plaster on the ceiling because we didn't need that moisture sort of regulation, and it was cheaper. And then that was sort of a little bit further on. It's not the latest photos, but that's what the living room is like, sort of like today. And then upstairs, that's what the staircase was like, and then we've taken this wall away and put in a landing and a new staircase up to the loft, so it's much brighter and feels great. So I think I'll come on to we did some insulation on the outside as well, around the back, because there was, as I say, there was a small extension which was a cavity wall, and I'll come on to that in a sec, but just briefly, all of the windows were pretty shot. Some of them were single glazed, so we decided to redo all of them. Because we decided to fit them ourselves, we were able to up the spec on those, so they're all triple glazed, which really does make a difference, especially when you can clear out that window and make sure all of the seals around it are sort of draft proofed and insulated well. So I mean, the cost of the glazing, I think we paid about around £7,000 for all of the windows and some doors, so it was a big saving in being able to do it ourselves, but then it did take us a long time to do it, so there's a bit of a trade-off there. And then this is just around the back where we insulated on the back walls. We had to push the windows out to be sort of aligned with the insulation zone. I won't go into that in detail, but you can see the newer windows in the front here. This is to be updated. There was a lot of concrete in this house. Around the whole landscape was mostly concreted for some reason. You can see a lot of it here. We've since had that removed, thank goodness. But they must have had some deals on insulation, on concrete. Can't remember what I put these images of the insulation on the back, but this is part of the rear extension that was on, where we decided to put external insulation on because the benefit of external insulation is it's much easier to apply. You have less issues around the condensation and moisture risks because you're particularly with the masonry building, the moisture is able to regulate inside as long as you've got good extraction and ventilation. So what we had to make sure was that any flues and vents that were coming out were able to deal with the thicker insulation. And then at the same time we had our roof done, which I'll come on to, and we got them to extend the eaves so that the insulation could really be quite consistent. Again, trying to get that the ceiling, the roof insulation and wall insulation to properly join so we're not having any gaps. So the roof insulation comes right over the top of this deck here, and the wall insulation came right up under that. So you can see in the loft here, what we ended up doing, we really wanted to go with a natural-based product in the roof. The trouble with that is that like I say, the U value or the ability of the insulation to hold that heat in. With natural materials, they often tend to be much thicker to get the same level as a Celotex plastic insulation, which had quite a big impact on the usability of this room, which is why we end up deciding to go with a higher performance product on that, so that we could keep the roof height down and give us a bit more headroom in the loft. So the roof needed work, so we had that replaced and had a layer of 75mm insulation added onto the rafters on the top. We will then add insulation between the rafters, which we're hoping to try and find. So all of that on top of the rafters was applied by the roofer. That was all brand new. One of the things George did a bit of calculations for his house and his loft was looking at the carbon footprint of the Celotex insulation. And it's slightly bonkers when you look at the amount of carbon that's used just to manufacture that insulation board compared to how long it's going to take to pay that off in terms of the energy efficiency that you're getting from it. It's really quite far further along than natural products, which are much lower carbon, kind of embodied carbon. So it's a real difficult one, and it's a challenge that the building regs are going to come across. There'll be a threshold where they can't keep saying we need to add more insulation because the amount of carbon that goes into the materials that make our houses more energy efficient is going to be more than we can actually save in the long run, if that makes sense. So what we're trying to do is, for the insulation that we're doing internally, because it needs to be cut anyway, a lot of people have offcuts, so we're looking online. Thomas and his partner Anna did a bit of a talk about sort of finding secondhand stuff as well, and they've been really good at that. There's so much stuff out there, but it does take time. So hopefully we can do that. And like any grand designs, baby came before the work's finished. You can, sorry, in that last picture you could see the ground. But so this is the rear. It was a real mess. A lot of the old cement render was completely shot because with the cement render, like I say, it seals. It doesn't allow the moisture to come in. But if you get a crack, then you'll get moisture getting behind the cement plaster, and then it debonds from the wall. So it can cause some real issues if it's with that cement render. So what we did was we paid a company to come and do this. They were fantastic, by far the best contractors we've had. And they, very similar process to this, but they used a sort of polystyrene type insulation, which is the sort of cheapest way to do it, mechanically fixed and adhered to the back wall, and then rendered over that. And it looks amazing now. It looks much better than it was. All new windows. And so we're really hoping that's going to make a big difference. I think we've noticed a difference already. Let me just check. So I think that's pretty much it. So that's kind of where we're at the moment. You can see all of the concrete's been removed here, and we've got still some work to do on this porch and stuff. And that stone is from the walls and that supported the joists under the floors that I showed earlier. So we'll use that in our garden to do some dry stone walls, which is great. Yeah, and we're still going, and it's been 3 years. So COVID didn't help with that, lockdowns, so that was difficult. So I guess just in closing, cost obviously was a big consideration for us. We really wanted to save our energy bills and sort of do right by the house in terms of the moisture not degrading the fabric, but also do right by the next occupants, so that, in terms of deep retrofitting and insulation, this house was good for them. But then we also had to balance that, A, with what we were able to afford, B, with the sort of precautionary principles around historic buildings, like, is this work going to damage the building? So a lot to consider there. Embodied carbon was a big one for us. What materials are we using? We really want to use natural materials. They're better to work with, more healthy, and they cost the environment less. Air tightness and sealing up any gaps can really make a difference. That can be a first port of call in some ways. But you do need to balance that with ventilation, your trickle vents and extract fans and things. And then the other thing we were trying to sort of keep in mind is, how is this building then disassembled and reused in the future? If we're going to be really serious about being kind to the planet, we need to think about how these materials are then reused in the future, or biodegraded, or buildings are adapted so that we're not creating more and more waste and issues. And then trying to use recycled materials as much as possible, which has been challenging, but yeah, it's been quite a process. So that's all for now. We thought maybe